Why there are high spots and low spots in the water table?
No.
Okay, thank you. First thing today, vocab words in the study guide, 7.2, go.
Which definition of condensation should we write?
Condensation? I don't really care.
Condensation nuclei. We're supposed to.
Condensation nuclei?
Both of those.
Condensation is just the process of going from spread out gas molecules to clumped together liquid molecules.
Great.
So it's a question of density, of pressure, of temperature, energy level, excitement. There's a lot of ways you can discuss that. I don't really care. Do you understand?
Mm-hmm.
You can say that any way you want. Condensation nuclei are the little bits of matter that a raindrop forms on. Every raindrop has a little bit of dust on the inside. It could be pollen, it could be spores, it can be plain old miscellaneous dust. It can be salt crystals. I'm forgetting something. There's a bunch of ways that you can build a raindrop. But here's the concept. Gas molecules are gas because they're really excited, so they're like bouncing off each other, like a really active mosh pit. And so when they smash into each other, it's like gas form. And in order for those water molecules to settle down and clump into a liquid, they got to give their energy to something that's called a condensation nucleus. If you're in a steamy shower, all the water droplets form on the glass of the mirror. They need a space to become water. So amazing reality, forest fires put themselves out because the ashes in the updraft meet moisture in the air and make raindrops. And even more amazing, rain dances actually work. The science of a rain dance was never how you dance or what you sing. The science of a rain dance was knowing that when the cold front is coming and you can see the clouds, you got to run up on the mesa and start kicking up some dust so that right at the moment where the cold front hits the mesa, the updraft carries your dust to make the rain fall. Rain dances are totally legit. And everybody's like, oh, that means if I dance like this, it's going to work? And like, no, you can dance however you want, but you got to make the dust at the right time. Condensation nuclei, that dust gives the matter that the moisture can form droplets on. That's what seeding rain is. Raise your hand if you've heard of seeding rain. So they make airplanes that have a special fuel that makes really dusty emissions, and they fly that through the clouds and it starts rainstorms. Yeah?
Real water.
As opposed to virtual water. Real water is the water that is liquid form that you know is water. Real water is just water. But virtual water is really important. Did I just spit on you? I thought I just spat. Sorry. Maybe I gotta eat that. Virtual water would be like how much water is used to produce an item. So back when this was a whole yardstick, you could say that that piece of the tree took 100 gallons of water. So 1/2 yardstick would be like 50 gallons of virtual water. When you trade stuff, it's important to know how much water is embedded in that. So that's virtual water. Like, anybody heard the thing about like cheeseburgers or almond milk or whatever?
I've
heard of just
so
almonds,
much virtual
yeah.
water.
Okay, yeah. So I don't know what that is. What, 50 gallons of almond or whatever?
I don't know.
It
But
takes
there's like
so
a
much water to grow almonds. They're horrible for the
Okay, well, that's the virtual water. If you could tell me how much water it takes to grow one almond, that's the
I
virtual
think it's
water.
1 gallon.
There you go. So an almond is 1 gallon of virtual water. Yeah.
I know you already explained this, but can you explain the difference between infiltration and percolation?
Going into the ground, moving through the ground.
In that order of what I said.
Right there. Infiltration is going into the ground. Percolation is moving through the ground. Anybody else? Okay then, I would like to explain this diagram. This is the last part of number 11, then we start skipping study goals going fast. In this picture, you can see that the water table is not flat. Which is kind of weird, because if you look outside, water's flat. The sea is so level, we call it sea level. I think everybody has a shared experience that if you take a bucket of water and you dump it into the pool, or a cup of water in the bath, or a mug of water in the sink. If I take a bucket and I dump it into the pool, is that going to make a pile of water in the pool?
No. That'd be cool. That'd be really cool.
If I use my empty bucket to scoop out 5 gallons of water, is that going to leave a hole in the pool? Well,
It levels out.
for a split second it does. If you like super slow-mo that, I think it's 0.2 of 1 second. There is a pile in the water, and there is a hole in the water, but the pile will quickly respond to more gravity at the top of that water stack, and so hydraulic forces will spread all the other water around and level everything. Like I said, 0.2 of a second, that hole in the pool water will rush back in, it'll slap into itself, it'll shoot up a little geyser, a little ripple effect, then it'll level out. Everybody seen slow motion water stuff?
The security lady thought it was a vape. Thought they were vapes, actually. That was fun.
Oh, I should call it right now. Got another one. In places where water goes into the groundwater, you get a pile for a little while. That'll eventually level off. In places where you suck out groundwater, you get a hole in the groundwater. That'll eventually level off, just like a swimming pool, except there's a lot of dirt in the way, so that's a lot slower. This water is wicking between really small spaces. So in places where water has piled up, it'll take like 1, 2, 3, 4 years, but that water's eventually going to go to sea level too. And in low spots where your well has removed groundwater, if you just leave it alone for a while, it'll start to recover. You've all seen this. There's another shared experience. I'll bet you at some time when you were a child, you went to the beach, and you were near the shore, and you dug a hole in the sand until there was water in the bottom, and then you threw the muddy water at Bronson Blix, and then eventually the water came back and filled that hole again. Raise your hand if you've had this shared experience.
Sorry, Bronson.
It's never too late. He's right here. The water moves slowly through the sand because it has to wick through all these little spaces. So, concept, all the world's groundwater is on its way to the ocean unless it's trapped by rocks. It's all moving. It just moves really slowly. And vocab, in recharge zones, like mountain tops that get a lot of rain, or surface water that soaks in recharge zones is a vocab term. You get what are called recharge mounds, like that high spot and this high spot in the water table. Recharge mounds form in places where recharge soaks in. Separate vocab term. In places where you remove groundwater, you get what are called cones of depression, or depression cones. I believe all this was in your vocab. Maybe you already got it. Casey, you have a question?
What is a Vados zone?
Vados is another way to say infiltration zone. Were you late or am I mistaken?
I was late.
You got a patch or something?
Yeah.
She's honest. It's good to be honest.
Fine, I don't need your stupid pass. Okay. Recharge bounds, recharge zones. Streams that are going into groundwater or streams that are coming out of groundwater, influent and effluent. I think I'm done with my number 11 vocab. Anybody want to ask me anything for number 11? Are we done with our intro to water? We're done? Okay, look. Number 12 just had some numbers. Almost all of it is salt. And most of the fresh is frozen. Of the liquid fresh water, it's almost all groundwater. Surface water is chump change. How many of you had those numbers already? Number 12? Moving on. Number 13. Don't forget that surface and groundwater interact in nature. Sometimes it goes into the ground, in some places it comes out of the ground. The diagram you just looked at. But what happens when we put humans in the middle? You were supposed to write down what's happening at 1, 2, 3, 4, 5. If you did that study goal. And so, like, in some places we extract groundwater, in some places we move surface water into the ground. Sometimes we hold reservoirs that recharge groundwater, like number 5 there. Number 4, sometimes we mess up our stuff with agricultural runoff, and so we add chemicals to groundwater. Okay, that's all good. I want to talk about number 2, because cities are weird. Cities mess up surface and groundwater. We got a field trip to look at how cities change water. Again, we're just really lucky to be taking this class in Santa Barbara. We've got like small, visible, explorable watersheds with lots of trails that terminate right in the middle of downtown that we can study in a single day field trip. We have like a well-known and well-studied history of activity here in town, so it's an easy place to do this. I want to talk about what's happening in number 2, what they call Sunlight City. That could be any city like Santa Barbara.
Maybe they're dead or something. Let's see.
Cities do two things.
Oh shoot, this is
That really change surface water and groundwater. We do 2 things. One thing that we do, we've gotten really good at solving problems from the 1850s. Raise your hand if you've ever seen a Western style movie or television show.
Oh.
Westworld is a classic.
Jose, you had batteries on your desk.
Yeah,
Shut up.
you had 2 AAA batteries. Do you want them in the green one or?
I don't know how.
It's pretty good.
Holy
That one's
mackerel.
pretty strong.
We could definitely blind someone with that.
Colin Wells, if you.
Oh yes, heavens to Betsy. My homie gives the best star tours of the National Park Service, and he uses a green laser, and he can basically point at constellations while he's talking. And there's enough like water molecules between you and outer space that you can basically make a line that lets you point at a star. And so he'll be talking to a bunch of people that are laid out on a granite slab at night, and he's got this like utterly soul-crushingly sexy voice. And he's super handsome and really knowledgeable, like totally spiritual and amazing. This guy's a god. And he uses his green laser to point at the stars, and it's like a spiritual experience. Oh, next level though.
What's his name?
Yeah, field trip.
His name is Eric Smith.
Oh, you told us about that guy a while
Oh,
ago.
I think about Eric Smith a lot. Yeah. I
Jose is so.
actually texted him a question this morning, so he's on my mind. Maybe I'll hear back. Why isn't he texting back?
Can we FaceTime it? Seriously.
It will blow your mind. I'll FaceTime him for you sometime this year. Let's find the right time. I'll get him on the FaceTime for you. Where were we? Westworld! Have you seen Westworld? Raise your hand if you've seen Westworld. Deadwood? Deadwood was good. Never seen anything Western? No TV shows or movies? So you've all seen them, but there's other ones. Fine.
Blazing Saddles.
Alright. Here he goes.
More like spaghetti western.
The reason that I mention Westerns is, in almost every Western there's a scene of it raining.
Raining water or oil?
Rain, water.
No, because there's always.
Shut up, shut up, shut up, shut up. 2 minutes up. No. I need you to imagine what a big problem rain was in a Western. If you were living in 1860 and you had to take your horse from out on your ranch to downtown to pick up a bottle of whiskey or whatever, you'd be on a horse for like 2 hours, and then if it was raining, you'd be wearing a whole bunch of like cotton and wool and leather, and you would show up all freezing and soaked, and it's like really hard to stay warm because there's not a lot of wood around to like do a lot of wood burning fires or anything. And everything is built out of wood, and there's like very limited waterproofing capacity. So everything's all like swampy and moldy and cold and crappy. And you'd be like dying of coldness, and your feet would be all fungusy and uncomfortable, and your back would be all clammy and cold, and like it's all muddy everywhere, and there's all this like poop on the ground, and so your horses keep like slipping, and if they fall you gotta shoot them, and now you gotta walk home.
That's quite a story.
Thanks. This is the nightmares that keep me up at night. I had to shoot my horse. It hasn't rained in a while, so you kind of have to use your imagination. You are the students that have been the most drought-stricken of any I've ever taught. Most of your days, you've been living in drought conditions. Last year was normal. That wasn't a wet year. That was just normal. This year, we're back to drought-like conditions. You guys haven't really seen this town with a lot of rain, but maybe you can remember that one time. If it rains, the roof will shed water like every other roof in Santa Barbara. All that water will fall on a sidewalk, which is carefully graded and brushed so that that water will spill at a very slow angle down to asphalt somewhere, and all that asphalt is graded so that there will be a little gutter of water against the curb, and that will go into a drain, which goes into pipes, which go out to canals, which dump water. You just need to find the closest permanent umbrella, like a building or an awning, and you're safe and you're dry. Your cars don't have to worry about getting stuck in the mud. You wouldn't have to shoot it if it broke its wheel. We've gotten really good at solving the problems of the 1850s. When water was a problem, you had to get away from it and get rid of it. And we do that now. In 2020, we just nailed it for the problems of the 1860s. We solved that problem. Easy money. We shed water and dispose of water. You know, if it's sunny after the rain, everything will be dry in 15 minutes. Water is a momentary blip of inconvenience, people will drive like a-holes, and then as soon as the water is gone, we're just like, oh, back to dry Santa Barbara, no big deal, like it never happened. Which is kind of funny because at the same time, we also needed that water and we just threw it all away on purpose by design. All civil engineering is just about getting rid of water. The angle of the roof and the way that you overlap the tiles and where you put the gutters and where you don't put the gutters and the grading on the sidewalk and the linking up of all the roads so that they all go downhill somehow. Like, this is all urban planning. This is how do we get rid of water. We've made cities to be impermeable so that they don't soak up water. And we've channelized that away to dispose of water. When it rains, we flush it away like a toilet. That's problem number one, because we have blocked recharge. We need water, and we can't store it into the ground because all our cities do is dispose of water. So problem number one, we block recharge because our surfaces are impermeable. Impermeable surfaces block recharge. Somebody did a study that Los Angeles County, do you all know how Los Angeles County gets all their water? From the Eastern Sierra, the Owens Valley, and from the Colorado River, the Colorado Water Project. How many of you had heard of that? The Owens water and the Colorado water from Los Angeles? Does everybody know that Los Angeles is a really big, crowded area? There's like, I don't know, 13 million people or something. It's like a third of our state all lives in Los Angeles County. Which is kind of a stupid place to put 13 million people because it's also one of the driest cities in North America. It gets very, very little rain. So, of course, if you got that many people, you got to steal somebody's water, right? Legend has it that if Los Angeles County could just keep their rainwater somehow, if they could just let that rainwater soak into the ground, there would be enough groundwater for all Los Angeles County's indoor water usage. So if LA kept the rain and killed the lawns, they could be water independent. I find that kind of striking. Of course, LA dumps all their water. When it rains, you gotta have a dry city because we're all afraid of living in a Western.
But if we solve the problems of living in the Western, can't we fix that?
Well, maybe, yeah. I mean, if we made our cities more inherently permeable, yes. Like cutting edge urban design, like when you get a hipster hired by the city, they'll be like, instead of grading everything away from the houses to the street, you should capture water on site. So at my house, we have low spots on the side of the house so that we can capture more groundwater and send less out to the street. It just helps my trees grow. Problem number two, we are effing disgusting. Just humans in general, especially you, but humans in general. What?
Why especially us?
Well, especially you.
Especially you.
Personally, you.
Your beard smells like
Apples.
Is there something
Because it's
wrong
clean.
with apples?
Very clean. I even oil it so food won't stick.
Just those.
I don't know if it's ever occurred to you how disgusting humans are. If you spend some time in like distant outdoors where there's no humans, things are really different. Humans are just gross. Speaking of gross, do you all know that there's like a homie on our campus that doesn't have a place to live and is probably a little bit off his rocker, and so he poops in public places? Probably out of frustration or anger, maybe, I don't know, it's hard to say. All over our campus every morning.
Was it the famous leak in the bottom of the
That
elevator?
guy. Yeah.
I was like, is it you?
Prove it. Yeah, so other than me, there's another guy who keeps pooping on the ground. He leaves turds everywhere. He leaves turds in front of Nicole McKee Barr's computer lab. and in front of Alma Gus's classroom, and all over our elevator and compost region, like right down there where I usually park my motorcycle. Because I'm like the first grown up in that part of campus, guess who gets to text message the principal turd pics?
That was it.
Lucky man.
Like 2 or 3 a week.
No wonder she liked you so much.
You know, you can do that thing where you go to your text messages and you go to the info button and it shows you all the photographs. You would not believe all the photos that I have sent to Elise Simmons of turds. I mean, like hundreds.
You show us and there's just a picture of your toilet. Some original artwork this time.
His chest.
If that guy wasn't using our campus, he'd probably still have to poop. And there's a lot of people that don't have a bathroom access. And in addition to all the poops that people may have to leave out in the field, think of all the people who have to pee out in the field. Like, I've done it. You know, like working at a construction site, you can't get to the porta potty, or you're out on the baseball field during practice and you don't want to run back to wherever you're supposed to go, so you just go into those trees on the hillside. Now, think of how many dogs are in Santa Barbara. They don't usually use a toilet. Some people put their poop in bags, but about half of them leave the poop in the bag on the trail.
That's like worse.
It is.
I know. You make a floaty plasticky version. Every cat, nobody picks up cat poop. How many people have an outside cat? Don't raise your hand, I'll just hate you. But all the people, oh God, I've always hated you. All those people, this is a funny coincidence, wow, okay. All those cats pooping outside, think of all the cigarette butts. Like every now and then you'll be like, whoa, you just managed your trash, and that's like a shocker. But everybody else you ever see smoke is just throwing their cigarette butts out. Think of all the drops of oil that come off our cars. Like if you have an old car that drinks about a quart of oil every 2 gas tanks or whatever, that means that you're dripping a quart of oil every 2 gas tanks. Every time I go to the gas station and I see that pallet of like 10W40 at the gas station, I'm like, there must be a pallet of oil that just went out on the highway because they're going to sell this in a couple of days. Cars that you have to add oil to, you're replacing oil that has fallen from that car. Think of all the pesticide and fertilizer, like all the truckloads that they receive at Ace Hardware, those are being deposited throughout Santa Barbara, and then they all go into the water too. Keep in mind that Santa Barbara will store all that for the 7 dry months. From average March 15 to average October 15 is a 7-month period where you just accumulate turds and urine and pet waste and cigarette butts, pesticide, fertilizer, oil drips, people washing out their painting supplies, dirty diapers, random cellophane wrappers for 7 effing months of like however many 300,000 people use our city or whatever. And then it rains. And you know, we built our cities to flush like toilets, and then we crap all over the city, so we just basically flush our turds downriver. Number 2 is, humans are gross. We really soil runoff. We make polluted runoff. Yeah. Conceptually, I'm sure this isn't rocket science because you've all lived in cities and you see it. By the way, some of us who've lived in less well-planned parts of the world may have seen some pretty horrible runoff from time to time. In the city where I lived most of my youth, the runoff would get really gross. I've seen like dead dogs floating out to the ocean and stuff, and God knows what. know, we could just build our cities better. Like, it's 2020. Like, now that we started to care about water, this is fixable. But we're living in an outdated urban design. We'll talk more about that. Number 14, you can just use your book. Number 15, there's this place that I can't pronounce. If everybody wants to just babble some noises, go ahead and get it over with now. If anybody knows the name of the Indians, I'd like to go with that pronunciation, but I still haven't found agreement on how they pronounce their tribe. I think it's Ogalala, which is just the most awkward word ever because it starts with like an in-breath. But the Ogalala, Ogallala,
I like
Ogallala Aquifer is in the middle of the United States. Can you all see the states on that map?
Nebraska.
There was a time when our continent had a gigantic ice sheet. Please look back here. Oh my God, I love that. Laser pointer! That's the best $10 I've ever spent.
That's how much
I think it actually got 3 of them for $10. If you could all look, that's actually halfway back. So at its extreme, when it was last coldest, the ice sheet came all the way down to Palm Springs, central Texas, across the bayou, and pretty much the only bits of land that stuck out was like whatever the Florida dongle looked like. So almost all the United States was covered in an ice sheet. As that starts to melt, that water soaks into the ground. And right here, in the middle of our nation, there's like a thin spot in the crust. So like the crust spread out like pizza dough and left like a thin sheet. So when the ice sheets melted, it just kind of pushed down the Ogallala Aquifer. Remember, an aquifer is an area of crust that holds water. See, area of crust that holds water. This has very little drainage to the ocean. It's like a big bowl just in the middle of the landmass. So basically, it's just water that melted like 15,000 years ago and has been sitting there ever since.
Why the farming is so good.
That's why it was so good. Yeah. And you can see where all the farming is, because if you look at the very top, you can see all the blue and green. That's where people have recharged groundwater. Those are mounds, high spots. So they take water out of the river, the Platte River, and they put river water into the ground, so the groundwater is kind of piling up where it's green and blue. Can you all see that? Kind of up in the north where Nebraska is, there's a river running right there. And then if you start to head south into Colorado, Kansas, Oklahoma, Texas, New Mexico, you see a lot of places where there's like yellow, orange, red, pink. That's where we have groundwater extracted to the point where we can't find the water anymore. It's gotten too deep, further than our pipes. That's called overdraft. Does anybody have a checking account? Nobody has checking accounts here? Do you know what an overdraft is? Overdraft fees or overdraft protection? What is that?
When you take too much than you have and then you get charged for it.
Right, when you spend more than you have. Does everybody understand how overdraft works in groundwater? Mm-hmm. You withdraw it faster than it recharges. Like a checking account. The Ogallala Aquifer is famous for a few reasons. Number one, it's the largest groundwater volume, I think, on the planet. I'm sure it's the largest in the US, but I think it's the largest on Earth. That bit of trivia may not be on the AP test, but the Ogallala Aquifer is famous for us having blown it. Like an idiot with the first checking account, we spent it faster than we refilled it. and then we couldn't pay our bills like a bunch of idiots. So we built cities on the Ogallala Aquifer, and then those cities couldn't supply water to all their citizens because some farmer nearby took out all the groundwater. And so there's all these ghost towns all over the Ogallala Aquifer. Can you imagine if the city sent you a letter? Like, sorry bro, we're out of water, you'll have to sell your house and move out. And you're like, who's gonna buy my house if there's no water? They're like, okay, bye. And it's over, and like total American dream collapse, like whole cities just like tumbleweeds, no joke. The U.S. had one of the largest groundwater supplies on Earth, and in some places we extracted it faster than it recharged and kind of ruined city planning in those areas. The Ogallala's world famous for this. Study goal number 16 is about desal. Do you actually turn oil into water?
No.
No.
Instead, you actually,
Use energy to make
Turn oil into energy and energy into drinking water.
what she said, oil into energy and energy into water. These are basically gigantic RODI systems, RODI systems, reverse osmosis deionization. Like if you have a system at your house underneath the sink that has like 3 thingamabobbers and then like a filling tank with like a horizontal one on the top, it looks like that with one of these, and then it has a thing like that underneath the sink, raise your hand. So that's a reverse osmosis system just like this one. But these are industrial, they're huge. I don't know if this actually fits your brain, but all of our water is delivered by gravity. Like, we store water above so that when you open the faucet, it's trying to get into your house. Every time something breaks in your house, it just floods because it's all under pressure because gravity. Unless you have to pull up water from deep in the ocean. So the suction requirement to like pump all this water uphill, and then the water pressure buildup to force it through a filter, this is really energy intensive. You may want to know that. The pumping uses energy, and the high pressure filters use energy. From there, you gotta pump it to the consumer, which uses even more energy.
Wait, pumping and what was the other thing?
Pump, high pressure filters, and then you gotta pump it up to the people. You still gotta get it to the humans. So desal is totally doable and totally a ripoff. Hell of expensive. Too crazy expensive. If you want to get rich and save human lives, you're a couple years late, but you should have been a nano engineer. Because people are trying to figure out how to make low price desal. And the way to make it low price is to make it low energy use, passive desal. If there's a way to make desal use less energy, a lot of humans will live better. For study goal number 17, we've talked about how cities affect water around them. For number 18, I'd like to show you some diagrams and you take notes on parts of this diagram. This is number 18, please look up. First of all, American human population keeps going up. Water usage kept going up with population until the 1980s. Look at that. Water usage started to go down as population was going up. Meaning per person, people started to use way less water. Per capita efficiency. Everybody understand what I mean by that? Since the 1980s, each person's been using less and less water. That's a very important positive trend. Since the 1980s. And I'll bet you that if I ask, what is the thing that you can do to save water, the most common answer is always the same. What's the one thing that mom's been nagging you about ever since you were 7 years old? And then the other one?
Turn off the faucet while you're brushing your teeth.
What idiot leaves it on?
I like the sound. I gotta tell you, that really doesn't, like, you can just leave the faucet open, I don't care. You can take long showers, it's fine. Look, let's be really clear about something. Everything that you do to lower water use is good. So great, drop in the bucket, hey, water. But if you look at the last 50 years of water use, or actually, anyway, if you look at these 50 years of water use, you can categorize America's water usage into public supply, like our houses and stuff, the rural supply, like unincorporated areas, like ranches and stuff. You can look at irrigation, thermoelectric, and industrial.
Irrigation meaning agriculture.
Yeah. And so if you look at all those cities and all those people and all their showers and all their toothbrushing, that's the blue color. If you look at all the ranches and stuff, there's just not a lot of humans, that's the green color. If you look on the fifth of these bar graph sets, that's industry. And actually, that's kind of an amazing success of the free market. Since you got to pay for water, efficiency is always profitable. It pays off. So you can see that saving water makes you a better business, and so industrial water use has gone down in the US. Congratulations, business world. But we're all kind of beating around the bush here. The giant elephant in the room is the brown color of agricultural irrigation, and even more, the blue color of making electricity. Like the steam goes back to being water, goes back to being steam, goes back to being water, but the coolant has to come from somewhere. In other words, 90% of America's water usage is food and electricity. And I'll bet your mom never said that's a way to save water. I totally roused my kids about saving water. But I always tell them, don't order that cheeseburger, turn off the lights. I actually don't really rouse my kids about this. But I hope you understand my point, that if you add together all the houses and all the ranches and all the businesses, that's only 10% of America's water consumption. Fun fact, anybody know what part of a residential water bill uses the most water? What thing that some of our houses do is the one that wastes the most?
Toilets.
Indoors you won with toilets. Total for the house?
Yards.
Yeah, irrigating lawns. I know that a lot of you don't water a lawn or don't have a lawn, and I'm not going to make you raise your hand, but if your parents have a lawn that they water with sprinklers,
You suck.
and everything's just average, that lawn equals 10 families' total indoor water usage. An average irrigated lawn, no, there's like, the average irrigated lawn in the United States is like less than 1/8 of an acre. So the average lawn in Santa Barbara County is bigger than the national average. That makes sense? Like, there's like that 4-acre lawn by Westmont or whatever. Like, you've seen some big lawns.
What? How big is an acre?
Times 100 square feet. Hey Siri, how big is an acre? Very good.
That helps.
Hey Siri, how big is 0.0016 square miles?
Dude, someone fucking make your phone. I know the junior high's like what? Is it
Yeah.
8 acres?
It says 43,000.
I really don't care. Here's what I did want to talk about. Lawns are way too much water use. And inside our houses, the one biggest water consumer is the toilet, which is kind of wacky because can I just point out that both of those are drinking water? And globally, 1 in 5 humans is water insecure. Like 1 in 5 humans does not have a reliable supply of drinking water. They could come to my house and drink it out of the toilet. They could suck on my sprinkler. I wash my dog with drinking water. If I were ever to wash my car, which I doubt, I would use drinking water. Think about the absurdity of our urban design. That any water delivered to you since the early 1970s, if you can control the faucet as a random civilian, so if you can turn it on, that's water safe to drink. Guaranteed by city, county, state, federal government. Not if you buy it in a bottle. Not if you buy it in a bottle. That's not inspected or verified.
Let's hope it's good.
You know, the business would go out of business because everybody goes like, boo for Aquafina, because some plumber didn't wash his hands down in Compton, and so when they were bottling tap water, a lot of hepatitis got into the Aquafina bottles, and so everybody was like, boo for Pepsi. That's a real story. That's a real story. Every part of that story is correct. We have like verified, certified, inspected, tested, stamp seal of approval tap water that is guaranteed to be safe to drink, delivered to all of our houses. And what I do at my house is I go like this so that I can put 1.6 gallons of that into a ceramic bowl. And sometime when I feel the urge, I irrigate that with urine, and then I press the paddle thingy, and it just goes away, and more drinking water replaces it for me to lay a turd into some other day. Send pics to the principal. We shower with drinking water. Every time my dog goes on a hike, he hops into the shower because he likes bath time. So he'll just run into the house and run into the kid's bathroom and push aside the shower curtain and just wait. He's a good dog. Good boy, Charlie, and then we hose him off. With drinking water. And then we go to like other parts of the world. Like sometime in this spring break, I'm going to drive a few hours to a part of the world where water's really hard to get. And like the water tank is on like a 3-minute timer so that people won't waste the very limited shower water, which is not safe to drink. It comes from a low quality groundwater source. The drinking water has to be trucked in from far, far away. And we have to use refillable containers to get our drinking water, and we have to pour that into our cups to drink it. And by standards of that community, we use more than 10 times the local water usage. And we just sit there and go, God, I hate this country. Boo from Mexico. And then we like go back to like the US and shower my dog with drinking water. Or go outside and just make it rain on my little green patch of fake Scotland with drinking water. world we live in. Our abundance feels so normal that normal feels weird. Like, go to another country and you're like, what do you mean you can't drink the tap water, you heathens? And then we just dump all that water, by the way. Get out of here. At my house, all the showers, oh, we can't stream this because it's illegal. All of my showers drain into a big tank outside, and I use a pump to take all my shower water, and I water all my fruit trees.
Why is that illegal?
Why is that illegal?
Because America!
But like capitalism.
It's literally just a conservation method.
Public safety, God knows what I do in the shower.
We didn't stop screaming that.
So gross. Oh my god.
And you know, it might like rain and stuff.
You just said that on camera.
That's okay, I meant butt juice. What did you think I meant?
I don't know. I wasn't paying attention.
So the whole point is you have to control like bacteria and runoff. So you wouldn't want like your neighbor's kid to drink my gray water when it rains. But I don't care, I know my neighbor, he's alright.
You only want your neighbor's dog to drink the
Their dog died. It was a little tiny dog and it would run outside and it was like totally blind and totally deaf. So it would just wander, like I found him in my house a few times, I'm like, so I put him over the fence. Number 19, you better have some good
I don't know
notes.
what you know that is.
I don't think this is.
Number 19, you better have some good notes. Number 18?
18. Wait, no. 19.
19, what do you want to know?
Then you were asking us what,
Shut up, Liz.
like,
Shut up.
how does like Phoenix and I never found anything
Oh, yeah, me
about
neither.
That actually came up in our movie, not in here, and I kind of patched together the breaks in the place wrong. So Tucson and Phoenix, they just have like mandatory efficiency standards. So you're only allowed to grow stuff that doesn't require irrigation. It's called xeriscape. And everybody has like low water use appliances and stuff. So they just keep their water usage really, really low by shutting out some of the big waste like toilets and lawns.
Okay, thank you.
Number 19, I'm warning you now, you'll need to take good notes because your book has one of those big lists of things in like 4 categories, and I'm not going to sit here and read the book where the book is fine. I do that enough as it is. Number 20, using groundwater sustainably is easy, like a checking account. Just don't spend more than you deposit. But also in number 20, it says, what's so special about our master plan? And I have to tell you that we're so lucky to live in this town. From all over the world, people fly into Santa Barbara to take a tour of our water system. Literally, like, honestly, no joke, like some of the highest paid city workers anywhere in the US are the snobs that run our water department because they're like geniuses and hotshots in this. It's like having Elon Musk run your local business development or whatever. Our water system is like unbelievable in a million ways. The secret is, this is probably notable, we have a variety of sources that are ranked by price and availability. So the easiest way to hold water is to just keep some rain around, so we have a bunch of reservoirs. Something else that we do is when the state has water and we don't, we can buy Central Valley Water Project water and stash it in Lake Cachuma. Lake Cachuma is the last faucet in the Central Valley Water Project. You all remember that from the agriculture unit? Central Valley Water Project? When we dammed up all the rivers?
Yes.
That pipeline ends at Lake Cachuma. So if we're having a drought and we don't have a lot of rain to put in there, but the state has a lot of snow melt in the spring and they can afford to sell it cheap, we can turn on the faucet and we can get state water. Something else that we can do, we have a whole network of groundwater wells. And maybe you know that Santa Maria area has a lot of farms, Guadalupe Dunes farming and stuff. So check this out. Our county bought an old farm and made it into a reservoir that's dry. It's called the Twitchell Dry Reservoir. Can anybody imagine why we would have a dry reservoir?
To fill it, storage
To
space.
Store what?
Groundwater.
Groundwater. It's a recharge zone. It's surrounded by really steep mountains. So there was this old farm, and the county's like, great, $2 million, $5 million, whatever. They bought this like giant farm, and they just put a fence around it, and then they left it alone. And as it happens, because it's surrounded by mountains, it's like a huge funnel to just take a bunch of rain and put it in the ground, so that that same groundwater supply can be extracted a few miles away for farms in Santa Maria. So we store groundwater. That's kind of a big deal. This is the best way on the planet to store water, is in the ground, because it doesn't evaporate. So groundwater is nice because you don't lose any to evaporation. Then something else we have in Santa Barbara is a desal plant. If we're really desperate and we're willing to pay for it, we can turn the ocean into drinking water. That's a bad move, but we can do it if we need to. And the last thing that we do, we reuse our wastewater. Anybody ever seen the signs, like in an athletic field? Like if you're an athlete, you know what I'm talking about. There's these signs that say not safe to drink, irrigating with reclaimed water.
They have that in most of the restrooms at the beach.
You're absolutely right, because those are city parks. And city parks are all using reclaimed wastewater. So after all of our water ends up at the water treatment facility, where we're going to go on Monday the 24th, they do like the full cleaning process, sterilize it, and then about a quarter of that water, instead of going to the ocean, gets pumped to nearby parks, schoolyards, and freeway medians.
What about water fountains at parks?
Water fountains at parks, those are drinking water. Technically, the reclaimed water is safe to drink. You just wouldn't want a lot, because there's like leftover medication and heavy metals and stuff in wastewater. Like the one thing we can't get rid of is like drugs and hormones and heavy metals in the diet. Like we make the wastewater undrinkable because of what's in our bodies. It's a crazy thought.
Cheers.
Hey, does everybody understand why reusing wastewater is a really good way to save drinking water?
Because then you don't have to use drinking water.
Because you don't have to use the drinking water for something else. That's right.
Is it possible to use reclaimed water in houses eventually for like toilets and stuff?
You totally could, yeah. It's just too much plumbing, but this is really common, like on boats and stuff where water's hard to come by. Like we built our nation on the idea that everything was hunky dory because baby boom glory. Whoa! Damn. Everybody caught that, right? We built this country thinking that we'd always have plenty of water. So we like bring some drinking water over here and then we get rid of it. And then we fill our toilet with other drinking water. But you can just like wash your hands and that pipe can go into your toilet tank. So that when you flush your turd away, that's the water that you washed your hands with previously. So it has some soap in it. Which probably cleans your toilet. Like that's actually common in really small buildings. Like you can order toilet lids that are a sink.
I know what those are.
Yeah, they're small and awkward and they don't fit in my aesthetic, so I'll just keep wasting drinking water too. And yeah, there's some ways that you can do gray water legally. So as long as it's gravity fed with no pumps in the middle, you're allowed to do that. but what the city demands is that it not be stored at all so that the bacteria can't grow in it. And yeah, you could probably use city water for irrigation at your house if you could pay for the plumbing, but pumping it uphill is really expensive. So that's why it's just some of the parks down by the beach, because they're already at sea level, so it's not too expensive to deliver that water. But you don't want to spend a lot of pumping money to reclaim water. I mean, we choose not to spend money to reclaim. Anybody else want to talk about Santa Barbara's water system? I got one thing left. It's our study goal. Sorry, it's our warm-up. It's our warm-up. And I don't know. I feel like some years all the kids find it in the book, and some years the kids are too lazy. Everybody remembers what wetlands are, right? Land that's sometimes wet. Wetlands are super key ingredient of our water systems, and we've developed almost all of them. We turn them into houses and we turn them into farms. My paper has 6 reasons why these are good for ecology or humans, and if you got them, we're done.
Just saying really quickly.
Number 1, wetlands recharge groundwater. Maybe you already had that. Number 2, they're hyper productive. So they're good for seafood and birds. That kind of blends together depending on how carefully you copy, maybe 3 separate bullets.
Is that like a nursery garden?
That's the nursery effect. Highly productive, good for fish, good for birds. Number 3, they clean water. That's called bioremediation, when living things solve a problem. So they improve water clarity and purity. They clean water. They make water cleaner. Number 4 is difficult for some of my students to understand because we're not afraid of the ocean here. Anybody ever been to a place where people are afraid of the ocean?
What do you mean afraid of the ocean?
Not like afraid to swim. I mean like, oh, or of pollution. Me too, but that's not what I meant. I mean places where like the ocean will kill you, like hurricanes in Louisiana, or like tsunamis in Indonesia. In places where the surges of the ocean can kill you, there's wetlands on the coast that can be really protective. Mangrove swamps, sandbars, cypress swamp, like in the bayou. As long as you're behind the cypress, hurricanes aren't scary anymore. So number 4, number 4. Coastal wetlands protect humans from storm surges. They slow down flood waters so you don't get smashed by a tidal wave or whatever.
Like the Channel Islands for us down here?
Yeah, conceptually, just like the Channel Islands protect us from south swell, they would protect us from storm surges. Technically, they're really far away and it's a different type of protection, but yeah, same concept, exactly. Number 5, we talked about the sponge effect before. Wetlands absorb water and trickle it out. So if you want to get good with words, they extend and moderate floodwater. They extend and moderate floodwater. Are you guys both wearing brand new Greeno gear? Dang. You guys got a hookup or what?
I don't know, this is my brother's thing.
Jeff Chamberlain's been posting all these old school photos of Greeno, like down at the beach with like his first 17-foot hole. And like, that's on my Instagram feed. And that makes me fiend.
Yeah.
Number 6. This is like a really good Swiss Army knife. You can use number 6 all over the AP test. Wetlands are a really good way to sink carbon. A good place to store carbon. So they combat global warming. Because if you can take biomass out of the system, then that's carbon leaving our atmosphere. So wetlands are a really important place to store carbon. You should know that in the United States we've used up more than half of our wetlands. In some of our states we've used more than 90%. Please look up. A lot of coastal cypress has been logged. And more common, a lot of coastal wetlands have been leveled to make them into farms like this. Also, a lot of waterfront has been made into cities, like the Bay Area. What's yellow is the historic wetlands of the San Francisco Bay. What's blue is the remaining wetlands of the San Francisco Bay.
Like dark blue.
Yeah. Wetlands are probably the most critical thing for land-water interface. Wetlands are really important to aquatic ecosystems. They're really important to human water quality, and we blew it. We just cut them all down and did other stuff there. Santa Barbara used to be all wetland. When you stand out here and you like open this door and you like see the city, pretty much if you see houses downhill of you, that used to be wetland.
What at the airport?
Yeah, that's right.
That's what
I mean, the airport is still wetland. Okay. Ask me questions between 11 and 21. Yeah.
It said wetlands are modified as a result of filling and diking. What's
What?
that? Filling and diking.
Yeah, sure. So filling is taking the low spots
Bless you.
and filling them in. So filling like this is filling. So that farmland used to be water puddles, and if you just level all that, you fill the low spots with the high spots and make flat
That's so
spots.
pretty.
Diking is damming. It's controlling water movement. So diking a river means to dam a river. Yeah.
In number 20, I really got grasp of what additional sources could be tapped
Wastewater.